Hello everyone, I'm Ramna from BSc Chemistry Honors final year. Today I'm going to read a chapter Water Pollution. Water in abundant amounts is required for use in agriculture, industry and household. After use, however, it gets highly polluted. The various water pollutants can be classified into as many as 10 categories. These are discussed below in some details. Various water pollutants. Number 1 is sewage and other oxygen demanding wastes. Sewage from municipalities and other oxygen demanding waste from industry and agriculture comprise of organic matter which undergoes oxidation readily under the action of microorganisms. These wastes are generally disposed of by dumping them into nearby rivers if the amount of sewage or other waste discharged is relatively small. The dissolved oxygen is sufficient to convert carbon into carbon dioxide, sulfur into sulfates, phosphorus into phosphates, and nitrogen into ammonia and nitrates, and the river water is not so badly polluted. If, however, the amount of discharge is heavy and the dissolved oxygen becomes insufficient, carbon is converted to methane and nitrogen compounds are converted to amines which give offensive odor of rotten fish decaying in a casa pool. The sulfur compounds change into hydrogen sulfide which gives smell like that of rotten eggs, and phosphorus compounds produced give a wormy odor. Thus sewage and other oxygen demanding waste become water pollutants on two accounts. They give rise to compounds which have an extremely annoying odor. They deplete the dissolved oxygen from water, which is rendered harmful because water devoid of dissolved oxygen cannot sustain aquatic life. It affects or even kills fish and other aquatic living beings. Second is infectious agents. Sewage from municipalities is almost invariably associated with disease microorganisms. This is due to the fact that in a fair-sized community, a few inhabitants at any given time must be suffering from diseases such as dysentery, typhoid, cholera, etc. The feces and urine of such patients would contain disease microorganisms which are transmitted through water supplies. Thus, wastewater from municipalities would almost invariably carry agents, bacteria, or other microorganisms which produce disease in other living beings, men and animals, including livestock. Plant nutrients. The presence of plant nutrients in lakes and slow moving waters introduced through runoffs from farmlands, sewage treatment discharges, and from fertilizer factories supports high population of aquatic plants which on decay produce disagreeable odor. Not only this, these plants also deplete dissolved oxygen, making the survival of aquatic life. The enrichment of water by nutrients is known as eutrophication. Lakes and slow-moving waters age through eutrophication, and over periods of several millennia, they get converted into swamps and marshes. Eutrophication has an adverse effect on fish as well. The aquatic plants which bloom in lakes sink in autumn and winter and decay the next summer, depleting oxygen from the lower, colder parts of the lake. The cold water fish, which according to Darwin's theory get habituated to require more oxygen for their growth, have to face shortage of dissolved oxygen. As a result, the cold water fish lose out to warm water fish which need less oxygen. Humans who prefer cold water fish are thus deprived of getting their choice fish. Number 4 is exotic organic chemicals. The exotic organic chemicals include pesticides, surfactants amongst detergents, many industrial products, and several decomposition of other organic compounds. Analysis of polluted water revealed the presence of a wide cross section of these compounds as also many others. These organic chemicals are generally toxic to fish. Some of these are toxic even at extremely low concentrations around 1 ppm. With the fast development of chemical industry, several new organic chemical compounds are introduced every year which may find their way into rivers and lakes. Since the effects of these new compounds on natural ecosystems may not be known, there is every possibility that an irreparable damage is done before scientists realize it. Number 5 is inorganic minerals and chemical compounds. A large variety of inorganic chemicals find their way into normal water water from municipal and industrial wastewaters and urban runoffs. These pollutants, comprising of compounds of Hg, lead, arsenic, cadmium, sodium, calcium, fluorine, etc., injure or kill fish and other aquatic life and also render the water unfit for drinking or for industrial use. A prominent example is the presence of mercury in water. At one time, it was believed that metallic mercury sinks into the sediments and remains there in chemically inert metallic form, but now it is known that anaerobic bacteria in bottom muds convert inorganic mercury into methyl mercury CH3Hg positive, which can lead to mercury poisoning in living beings. In petroleum drilling, brine is discharged along with crude oil when the latter is pumped to the surface. Sometimes the volume of brine may be more than 3 times the volume of crude oil recovered. This brine is a potential pollutant for water. Minerals containing sulfur, for example iron pyrites, copper pyrites, on coming in contact with air and water yield sulfuric acid, which is carried into lakes and rivers by water draining from the mines. The presence of the acid affects aquatic life. In cold countries, NaCl and calcium chloride are added in large amounts to melt snow from the roads in winter. These salts eventually run off the roads and contaminate well water and also find their way into lakes and rivers and seriously affect the aquatic life. Some other metals whose compounds frequently act as water pollutants are lead, arsenic, and cadmium. Lead compounds of lead which enter into water are lead chloride, lead bromide, lead bromine chlorine, lead oxide, lead sulfide, which originate from lead minerals. Lead in the form of lead hydroxide gets its entry into water from lead pipes. Excessive intake of lead by humans causes disruption of synthesis of hemoglobin. It also results in loss of appetite, anemia, kidney malfunctioning, nervous disorder, and brain damage. Arsenic. The main sources of arsenic compounds in water are pesticides, fungicides, and herbicides. Arsenic contamination may also occur due to discharge of some industrial waste. Dissolution of arsenic minerals is another source of arsenic compounds. Arsenic compounds are highly toxic. The toxicity arises from the complexation of arsenic with the SH groups of enzymes, which leads to inhibition of enzymatic action in human body. Since arsenic is structurally similar to phosphorus, its presence interferes with the process of phosphorylation in human body. Higher doses of arsenic result in coagulation of proteins, which causes cramps, paralysis, and even death. Cadmium finds its way into water from industrial discharge and from nickel cadmium batteries. It is highly toxic. Excessive dose causes kidney malfunctioning, anemia, disorder of bone marrow, etc. It may be mentioned that according to the International Register of Potentially Toxic Chemicals of United Nations Environment Program, there are nearly 5 million known chemicals in the world today, and about 40,000 new chemicals are added to this list every year. Of these, about 75,000 chemicals are in immune use, amongst which a large number are positively known to be toxic. A brief list of toxic elements whose toxic ions are most commonly present in municipal and industrial waters is given in table along with their sources and adverse effects. So, element is arsenic, sources are pesticides, chemical wastes, mining byproduct, and effect are enzyme inhibitor, carcinogenic. Element is beryllium, sources nuclear power and space industries and coal. An adverse effect is toxic, carcinogenic. Element is boron, sources are industrial waste, detergent formulations, coal. Adverse effect is toxic to some plants. Element is cadmium, sources are industrial discharge, metal plating, nickel cadmium batteries, mining waste. Adverse effect causes high blood pressure, kidney malfunctioning, anemia, disorder of bone marrow. Element is chromium, sources metal plating industries. Adverse effect is chromium is carcinogenic. Element is copper, sources are metal plating industries, mining, mineral leaching. Adverse effect is not very toxic to animals, toxic to plants and algae. Element is fluorine, and sources are natural geological sources, industrial waste. Adverse effect causes bone damage, mottled teeth. Manganese mining industrial waste microbial action on manganese minerals of low pH non-toxic to animals toxic to plants stains materials. Selenium, natural sources, sulfur, coal, toxic, zinc, metal plating industries, industrial waste, toxic to plants. As is well known, the normal growth and development of animals and human beings are brought about by specific enzymes present in their bodies. The toxic ions in general attack the active sites of these enzymes, react with the SH groups of the enzymes, and this causes their complete inactivation. As for example, the functioning of metalloenzymes is inhibited by the replacement of the harmless metal ions of the enzyme by the toxic metal ions. It is to be noted pertinently that it is not the presence of a particular chemical but its concentration which actually matters in chemical toxicology. These elements such as arsenic, aluminium, antimony, BaBe, cadmium, cobalt, copper, selenium, lead, molybdenum, mercury, zinc, etc., which are listed as environmental hazards, act as nutrients in trace concentrations and are essential for normal growth and development of animals and human beings. Arsenic trioxide, a deadly poison, is known to act as a tonic at trace concentrations. This means that for pollution control, we have only to control the concentrations of the toxic elements. Any number of toxic elements may be present in drinking water, but as long as their concentrations are below the prescribed limits, they are harmless. The permissible limits for some common elements, as laid down by the United States Public Health Drinking Water Standards, are given in Table 3. The BIS Bureau of Indian Standards values, wherever available, are also included in the table. The drinking water should be colorless and odorless. Its pH should be lie between 6 and 9. It should be free from harmful microorganisms and its dissolved oxygen content should lie between 4 and 6 ppm. It should not contain the above mentioned chemicals beyond their permissible limits of concentrations. Sediments are particles of soil and minerals which are washed from croplands, undeveloped lands, unprotected forest soils, overgrazed pastures, strip mines, roads, bulldozed urban areas, etc. by storms and floodwaters. Sediments fill reservoirs and stream channels, plug water filters, erode power turbines and pumping equipment, and reduce the amount of sunlight available to green aquatic plants. The sediments also cover the fish nests, the egglets by them in water and their food supplies. This reduces the population of fish and shellfish. Number 7 is radioactive substances. Radioactive substances from nuclear power plants, wastes of uranium and thorium mining and refining, and from industries and institutions which utilize radioactive materials, if carried by water, become sources of harmful radiations. Heat. Large amounts of water are used for cooling purposes in thermal and nuclear power plants. Water is also used as a coolant in some industries. Cooling water is discharged at a raised temperature. The increased temperatures have several adverse effects on certain properties of water. The rates at which chemical reactions occur increase considerably. This results in faster assimilation of water waste and hence faster depletion of dissolved oxygen, which affects aquatic life. The rate of evaporation also increases appreciably with increase in temperature. This results in greater wastage of water in the form of its vapor and so on. Oil pollution results from the discharge of oil from oil tankers and offshore drilling rigs accidentally or intentionally. An example of accidental oil discharge. Number 10 is detergents. Detergents comprise of surfactants, that is surface active agents, which are organic compounds having polar or hydrophilic groups such as CHH, SO3, HNH4 positive or non-polar group soluble in water. Some common detergents are given below: linear alkyl sulfonates, alkyl benzene sulfonates, quaternary ammonium salt, polyoxyethylene, phenol, where R, R1, R2, R3 are straight hydrocarbon chains. R4 is an aromatic chain. X is a halogen or an acid group. M is a cation such as Na positive. The surfactants in detergents cause a variety of pollution problems, some of which are as follows. The surfactants are highly resistant to the action of biological agents and thus do not undergo biodegradation. Since the surfactants tend to retain their identity, their elimination from municipal wastewaters by the usual treatments becomes problematic. Surfactants tend to inhibit oxidation of inorganic substances present in wastewaters by forming a sort of envelope around them, with the result that these substances do not undergo oxidative degradation during the treatment of wastewater. These substances, generally being toxic, cause severe water pollution to which there is no remedy. Being surface active, the surfactants cover the surfaces of small particles in colloidal suspensions, thereby stabilizing them considerably. These colloidal particles do not aggregate and hence cannot be easily filtered off during subsequent treatment. The stabilized colloidal particles also reduce the activity of biological filter beds and activated sludge. The most undesirable effect of surfactants is their tendency to produce stable foam in rivers, sometimes several meters high, especially at low gates. These foams extend over several hundred meters of the river water. The builders used in the preparation of detergents mostly consist of sodium phosphates, which form stable soluble complexes with hardness liberating ions such as Ca2 positive and Mg2 positive. These complexes act as plant nutrients and support rich growth of aquatic plants, which deplete dissolved oxygen when alive and produce disagreeable smell on decay. In view of the above problem, research is now going on to discover surfactants which are biodegradable and builders which are non-phosphatic. Thank you.